তো আমরা প্রথমে আমাদের প্রোটিয়াস সফটওয়্যারে চলে যাই, যেখানে আসলে আমি প্রজেক্টটা রান করতে পারবো। তো আমাদের প্রোটিয়াস সফটওয়্যারে আমরা একটা নতুন প্রজেক্ট তৈরি করি। দিস উইল বি আওয়ার নিউ প্রজেক্ট and we rename it as solar controller project. Okay, our system is ready, and now we are taking some essential element for our project, which is a relay. I am taking this relay. We need some Zener diode. We need some Zener diode, and we add this. And we need some battery. We also take it. We need LED. Okay, all of the element which we need is completely added here, and now we are simulate it. So first of all, we should replace the battery. We think that we have two battery in our system. To develop this project, first I have to place one battery, which is number one battery, and we need a Zener diode. I am replacing here, and now I just connecting them. We need some relay. There are two relay just because we have two battery in our system. We change our relay potential value, which is equal to 5 volt. Sorry. We also set this relay to 5 volt. Now we're connecting them. And here the approximate voltage will be around 10 volt. Okay. So we're connecting both of our relay with parallel connection so that the maximum amount of charge will be passes through the relay, but there will be no fault with respect to current. And now we're connecting our relay to parallel situation. So first of all, I want to declare that our first terminal, which is called NC, normally closed terminal, which is shown here. This is the normal closed terminal. We set normal closed terminal for battery 1, and normal open terminal, terminal number 2, is for battery 2. And now we are connecting both of them. So as well as normal open terminal goes to battery 2, and all of our negative terminal will be shorted together. Okay. So we think that we have a power source which is come from solar, and the potential difference is very high, approximately 18 to 20 volt. Okay. So we set it for 18 volt, and now what it will be going, that our negative terminal will be connecting on negative. And now, okay, let's see that what it can going to operate. So first of all, we run this program and see what is happening here. That we can see our 12 volt system are not changing its proportion, just because this battery voltage is under our control voltage. And if when the battery is full charged and the voltage raised to 14.5 volt, then what happened? Then we can see that our normally closed terminal has been shipped to normal open terminal, and our second battery is going to be charged here. Okay. So if our battery voltage is more than 14.5 volt, then our channel will be shipped from normal close to normal open. What happens if our battery voltage level is just 14.0 volt? Then you can see that our normal closed terminal cannot be sensed. So this is our limited voltage, and 14.5 it is our cutoff voltage. Okay, you can also sense this system with respect to Zener diode and our input voltage. So now we are changing this property. What happened if our second battery also reached its maximum voltage, which is 14.5 volt? Then we have to stop our charging because our both batteries are become fully charged. So here we are going to use another product, and we use Zener diode here, and the secondary terminal of our Zener diode will be connected from battery 2, and this is our solar input battery, which is used as purpose as solar. This is our high voltage difference, which is 18 volt, and this is our normal closed terminal, which is shipped at power terminal base. This is only for power terminal, and this power terminal will be controlled on this channel. And our another terminal will be connected to negative terminal. Okay, now what happened if we set the value to 5 volt and our Zener diode level will be 10 volt? Okay, now what happened if our both batteries are reached at maximum voltage level, which is 14.5 volt and also 14.5 volt? Now what will be happening here, that we can see that our first relay, which is our control output relay, has been shipped it line to normal close to normally open. In this case, that no battery will be charged on from solar panel. Our solar panel terminal will be removed here. That you can see easily that this is our output terminal, which is perfectly shifted. So in this case, there is no chance to overcharge. So this will be our initial system, and now we are going to add some load here. That's why we are connecting here a green light, which is very simple as you see here. And for more specification, we are adding some DC voltage meter to see the approximate voltage here that will be passed on LED. Okay, so we run it, and what can see here that 14.5 volt. That means the second battery voltage are being shown in across the load. What happened if our second battery are under low voltage, which is approximately 9 volt or 10 volt? Then we have to check it. So we use another relay here. Okay, this is another relay which is connected in this input, and line will be shift on from this terminal. Okay, and we're using a Zener diode here, and our Zener diode will be connected to here, and we set it for around 14 minus 9, which will be approximately 5. Okay, so we set it for 5 volt. Our negative terminal will be connected on battery's negative portion. Okay, so now we are going to see that what will be happening here. Okay, we have to change our relay battery level, which is to 5 volt. And now we can see that our output voltage has been shifted to this terminal. That means the battery level is perfectly open, but the output current is showing that 14.5 volts just because our okay, now we are going to see that what happen if we reach our battery level to 9 volt. We set the generator to 5 volt. Okay, so our battery are going to be charged from this 9 voltage. So this problem is created for this situation just because this is our low voltage battery and our solar is charging to this battery, and that's why the bulb is running. If this is in night condition when our solar panel is open, in this case you can see that our relay does not open and our load will be closed. Okay, now we can transfer our a single wire on from this level, and this will be shifting on here. Okay, we also see here that no current will be passed through this LED. And now if you have a question that our in fast battery is fully charged, that why our load is not running. To run this system, we again use this particular portion on this terminal here, and we have to run it. And now what we can see that we can see that our solar system is deactivated. This is night and our solar system is deactivated, but we have two batteries and our second battery is under low voltage, and that's why we are operating our load from our first battery which is fully charged. And if the solar system again is started, then we can see that our second battery are being charged, connecting from normally open loop, and you can see that our first battery is fully charged. That's why our first battery cannot taking charge from this system. Also, our load is operated at fully voltage, which is 11.6 volt. So this is our system. And now if our second battery are also operate at full charged voltage, which is 14.5, and now then our solar system are being cutted out and no extra voltage are passing from our battery, and our system is also running here. If both batteries are out of control, I mean low voltage system, For example, 9 volt, and our initial battery are also same as 9 volt. Then we also has been removed from our total system to both of them battery. So we are taking a relay. Here, this is a relay, and we need a zener diode here. We just mirror them and connecting on this line. Our negative part will be shift to here. We set our relay value to 5 volt, and this will be our 5 voltage system. And now we're connecting on that loop. So basically what is happening here, if our solar system is out of our system, then our no load is operated here. That's because there is some problem, which is our second battery are low voltage. You can see here, this is just 9 volt. Our fast battery has the low voltage, that is 9 volt. That's why both of our battery are been out of our system. So this prevent our load from low voltage saturation problem. If our any batteries are over 9 volt, I think this is 10 volt battery, and of course the LED will be running, our load will be operated. So this is the prevention from overload, over voltage and under voltage situation on solar system. This system also be applicable here if this is a current IPS system. We can also use this simulation diagram to any IPS or solar system. So thank you everyone to watch my video. If you have any questions, feel free to ask me. My Facebook account has been mentioned in our description box. Okay, no more today.